Hi, we're going to take a look at Rigol's new DL3021 or DL3000 series electronic loads. We love electronic loads here on the EEVblog. I've done like a do-it-yourself electronic load video, which I'll link in at the end and down below, which is incredibly popular. People build their own, but you can't beat a nice commercial electronic load for power supply testing, battery discharge testing, solar cell testing, all that sort of jazz. So let's take a look at it. Now, this is the DL3021. It's actually the bottom range unit, $499 US, which puts it about in the middle of the commercial electronic load market. Companies like Kikasui make sort of, the top shelf electronic loads. This is on par with like your BK Precisions and your Arrays and iTechs and ones like that. And then you've got your much cheaper ones, your no-name clone copy ones, your Mainuos or whatever they are on eBay and things like that. So it sits somewhere in between. It's a 200 watt load, 150 volts, 40 amps. Now, don't confuse this with the DL3021A on the end of it. The A model is actually $300 more, $799 US retail. And what do you get? Well, having a look at the data sheet, the manual for this thing and the specs, I'm having a hard time finding the difference. It seems to be the 0.1 milliamp resolution readback current as opposed to 1 milliamps for the non-A model. But apart from that, they're both 0.05% class electronic loads, which is what you'd expect in a precision DC electronic load in this price range. 100 ppm, they're all the same Temco. It's got slightly different ranges on constant resistance modes and things like that, but there's not much in it. I don't understand why they make an A version. It's just stupid. Just make the $499 version with the A functionality extra, whatever the hell that is. It probably doesn't cost you anything at all. It might be like software options or something like that. Just make one model. Thank you very much. Anyway, there's the 3031 as well. Once again, a non-A version. It starts at $999, so $1,000 goes up to $1,500. And the only difference in that is it's 60 amps capable instead of 40 amps, but it is 350 watts as opposed to this 200 watt model. So anyway, this 200 watt model, good enough for, say, a large solar panel testing, things like that, large battery packs, stuff like that, plenty capable for things like that. Now, it's your traditional new Rigol look and feel with these rubber bumpers on them. You either like them or you don't. They're like, meh, whatever. Okay, we've got a large screen on. We'll power it up later because we want to tear it apart first. And we've got one knob on the thing and a keypad arrangement, your various functions in here. And they've put the sense terminals on your front, your binding post, a USB on the front, and, your cursor keys, whatnot, and your various config keys up the top. It's a reasonable layout, but just look at this thing. The first time I saw this thing, my head started to, twitch to one side and I started to get a nervous tick because look at these bloody buttons here. Reverse italics. Buttons. Look at them. Look at them. Whoever designed that should be hung, drawn and quartered. It's ridiculous. The italics sloping backwards and the buttons sloping backwards. Why? The humanity. Next up, I'm no graphic artist, but what the hell is up with the fonts on this thing? What is this function font? Look at, I think I posted this on Twitter, a photo of this. I think somebody counted 4, maybe 5 different fonts used on this thing. It's just insane. The different fonts. Why? Why? Who designed this? They shouldn't be in the business. It looks like someone's just throwing up the font list. Illuminati confirmed. What the hell is that? What does that even mean? It's not even labelled. It's just creepy. Now, I like the fact that they put the sense terminals on the front, shrouded 4mm banana plugs, but I would have liked just the old school screw terminals as well. So, and sorry, but the binding posts are a complete and utter fail. Why do companies keep making that do these electronic loads? They all seem to do it, make ones with no banana plug on them, no hole inside the thread, inside the shaft there, so that you can shove your wire securely in there. They just have these ridiculous dumbass binding posts like this. They're so frustrating. You have to end up making your own little adapter to convert them to what the hell you want. But check this out. This is kind of interesting. You see the thread here. I thought, that might be for some optional adapter. They actually include this plastic shroud in here, which just has some cutouts at the bottom for your wires, and that just sits on there. They've got magnets on there, and it just attaches in there. The magnet over here is not great, and then you can just screw that eventually straight into there. It's only 150 volt rated, so it's designed for, so you can't touch these things, but I don't know. Okay, cute, I guess. Nice touch. Now, as for the key layout, it could certainly have been better. I mean, you've got all your constant current, constant voltage, constant resistance, constant power, and your other, looks like there's a pulse mode, a toggle mode, a list mode, and stuff like that. So I don't mind that. Your on-off button probably should have been down here next to your output or something like that. Perhaps transient short is interesting. I'm curious to find out, what does it just short out the internal current shunt? Not sure what that is. Anyway, your cursor keys, the knob here is not pushable, and the italics ones up there are so triggering. Anyway, it's okay, but they could have done better. And I like the dedicated application button here, battery, OCP, and OPP. I'm curious to check out the battery functionality for measuring your characteristic curves of batteries. On the back, made in China, of course, but look, it's fully featured for the bottom of the range unit. You've got some digital I/O for programmable control switching and test fixtures off and on. You've got your LXI LAN interface, fantastic USB device, or old school RS-232 serial, current monitor output and voltage monitor output. Very handy for hooking those up to the scope. Nice. All right, so let's crack this thing open. Just take the handle off the side and the 4 feet on the bottom, and slides off just like most others. And we're in like Flynn. Geez, I'll have to sit it up for you, but hang on. We'll take a squeeze. Ooh. I'll tell you what, this looks quite neat and tidy. I really like it. We'll show you up close. It's hard to sort of get in here without taking the whole blinking lot apart, get detail on the board and get light in there and stuff, but I really quite like it. Anyway, thermal wise, we've got our entry on the side here and here through the hole, the grill on the side of the unit. The fan inside then sucks the air from here, pushes it through our finned heatsink, which has all our power trannies on there. You can see those down in there. There's some on the other side as well. Not even number, so that's interesting. And just dumps it out the back. So the thermal design, that's as good as you can expect. And this is the 200 watt model. So the upper model is the 350 watt model. So presumably it either has some more power devices on there. I can see some extra footprints down in there. There we go. It looks like it's going to have the same heatsink and everything. It might drive the fan a bit quicker. We've got some extra footprints down in there. So maybe it's just a matter of extra power trannies on the upgraded unit. In that case, why does it cost, for this one's $499, the other is $1,000. Why does it cost $500 more, double, to get the extra power trannies if all the heat sinking and everything else is the rest of the design is going to be pretty much the same, because it's 60 amps versus 40 amps. That's really gouging. Just make one model. Just make the 60 amp model for $499 and you'd kill the market probably. Come on. But okay, it's got some extra power devices, and I don't mind paying for an increased power model with extra parts, but not double. That's just, no, not on. Now this is absolutely fascinating. Look, they've used a PCI expansion board in there for all of your I/O capability. That's really quite nice. I like that. Nothing wrong with PCI slots. They're, readily available. They're never going to go obsolete. They're used in too many things. They're cheap. They're simple. They've got lots of contacts. They're reliable. They're proven. Everything else, it's nice to see a PCI board in there like that. Hats off. Okay, our mains wiring. I like the earth terminal going off there. That looks properly crimped and shake-proof washed. No worries, it's all heat shrunk. Goes on to the main PCB down here. That's the mains voltage selection. So they're doing some main selection around there. You can see the high voltage isolation slots in there. Very nice. And then they've got that wiring going over there, running through there, cable tied nicely, and that goes over to the real clunking power switch on the front, which is actually mounted on the main PCB. So once again, that's quite nice. They've left the tons of isolation space in there, so no worries whatsoever. Rigol, innovation or nothing. Is this a new slogan? I don't think I've seen that before. Anyway, designed in China. They're quite proud of it, and rightly so. They're doing lots of nice R&D. And that transformer looks nice there. Nice little small linear jobby, because this is not a power supply, it's a load, so it doesn't have to power much. It's just got to power all the digital and analog circuitry. That's it. So AC in, bridge rectifier. We've got our filter cap. We've got a couple of small heat sinks here. Have to get the thermal camera on those, I suspect, because Rigol have goofed up that in the past, although be careful getting the thermal camera onto just the anodized clear aluminium like this, because your emissivity readings will be crap. So you're better off maybe getting a thermocouple on there to measure that. But of course the test would be the old finger test, leave it on for a while, and it shouldn't change with the what load it's producing and stuff like that. So as long as you can keep your finger on there, it's under 50 degrees, she'll be right. No worries. So that all looks fine and dandy. You can see the high voltage isolation cutouts there around the MOSFETs. So, yep, they know what they're doing. Nice touch. And the electrolytic cap, that symbol there is a Samyang. So they're Samyang KMG series. Par for the course. Now for the main chip in there, I'm surprised to see a Spartan 6 in something like this. I mean, they must be running like a soft-core processor in there, I would be guessing, to do all this. They could do it all in VHDL or whatnot, but yeah, my guess is they're running some sort of a soft-core processor in that, but all the rest of it is just all the miscellaneous, analog. It'd have the ADCs and the DACs and whatnot all around it, but that's pretty much all she wrote. But the interesting thing to note is this ribbon cable here, of course, goes off to the front panel board. That's got another Actel FPGA. We'll have a quick look at that. But the traces don't go off to the Spartan 6. Look, they bugger off all the way around here, right behind the transformer and everything else. They run in all the way around here, coming right to the back and go into that PCI card, which controls that. So maybe the processor is actually on the front board, and that FPGA is just doing all the the data acquisition stuff and things like that. Because otherwise, why would you have the I/O card there flowing into the front panel board? So yeah, I take that back. The Spartan 6 is. It might still be running a soft core, but it's not doing all the main processing and display stuff. And can't quite read that on the screen, but that's some sort of Freescale processor down in there. Is it holding the doing all the digital I/O stuff? I can't actually get this PCI card out without actually taking out the main board. It just does not come out due to the D9 connector, serial connector on the back. Bummer. As for the front panel board down in there, an Actel Pro ASIC 3. I'm curious that they've used like an Actel one and then a Spartan one, a Xilinx one. So, two separate brands. They probably have different development teams working on these. So they just chose their flavor of FPGA. Actually, given that there's only the Actel Pro ASIC 3 FPGA on there, Spartan 6 down there, I am going to say that Freescale processor down in there is the main processor for this thing. And in fact, they call this a digital board, if you can see the text down in there. So it's not just an I/O board, this is the digital board. So this is the digital processor board for the whole thing. So that is the main processor. Kind of, not a bad decision to put it onto a PCI card like that. You can swap it out later without changing your main board. That's, and your display board as well. That's quite smart. Now, as for the input over here, very, very nice. I love this, and it's common that you'll find these on big loads like this. The huge binding posts, just huge bus bars directly out straight onto the PCB copper. Just massive pads, massive amount of copper on the PCB there. And it looks like we've only got the one current shunt resistor. That one down there, you might be able to, might have to get the macro lens on there, but you might be able to see little traces coming out there. That's the pair coming out for the 4-wire sense. There we go, you should be able to see that. Just one pair coming out there. That's just the sense wires going into the sense amp down there. Now, you might be thinking, hey, this is a shunt resistor. That's a 4.7 ohm, huge couple of what is it, a 5-watt jobby or something? I don't know. It's quite large power one. And no, that is not a current shunt resistor. That is not a low ppm. Current shunt resistors don't have to be accurate, as I've said many times before, but they've got to be very stable, so they've got to have a low temperature coefficient. This looks like just a Joe Blog's power resistor, so that's just part of some snubber, RC snubber type network there happening. So looks like we've only got the one current shunt resistor down there, very low value jobby. Now, whether or not that varies between the regular model and the A model, I doubt it. I think they're using the same current sense resistor. The sense network could change. They could get extra resolution, but I think it's just probably like a software type difference there. So this is the difference between, they would be getting the non-A model, which we've got here, has 1 milliamp resolution, I believe, and the A model has 0.1 milliamps. So, order of magnitude better, but they're probably still using the exact same current shunt resistor. And for you power tranny fanboys, there you go, international rectifier. Can't quite make out that number on the LCD, but I'll read that back. Include the data sheet. They're probably like matching devices in there all the way along. So I've got it, as I said, it's difficult to get this board out, so I'm not going to bother to see the other ones. But each channel has 6 of those, and presumably the A model with the 60 amp capability is going to have the extra 2. So it'd have 8 devices per side. There's certainly been a bit how you doing with the heatsink compound in there. Check that out. Jeez. So I'd like to go into more detail and trying to get that board out, but it looks a little bit ugly. I don't think we're going to learn a huge amount more. Just suffice it to say that this thing is quite well designed and manufactured. I can't find any issues with this thing at all. So yeah, I'm just excited to power it up and have a little play with it. Not sure if you can see that, but the buggers have lasered off the markings on these 4 SO8 packages here around the current sense amp. Stop it! Just stop it! And they've done the same bloody thing for the op amp around the MOSFETs there. Why? Oh, unbelievable. Just see if we can see the other trannies down in there. Not sure. Can't see it on the LCD. And that connector down in there, obviously going off to the sense wires on the front panel. Got a relay, notice the isolation slot, and also some input divider or protection resistors, and once again, more high voltage slots there. Only 150 volts, so you needn't do that sort of thing for those sorts of voltages, but hey, over voltage and stuff like that, no worries. But it does show nice attention to detail and more slots cut around here. So yeah, somebody just went, yeah, I'll put a slot in because that's the thing to do. And I'm not sure what's going on with those plated holes. Input -1, 2, 3, 4. Like, I don't get it because they're just one big copper pad with plated through holes. I don't know. They're not like current shunt jumpers or anything like that for big current shunts. Obviously some sort of extra mechanical interface which they didn't use. They went for the other two big bolts down there perhaps. Alright, so let's power this baby up and have a quick play around with that self-test Rigol. Come on, you can do it. Wonder what OS it's running. Come on, it's only an electronic load. Self-test. Twiddle thumbs, and here we go, we're in like Flynn. Now I don't mind the interface, it's not too bad at all, displays the current voltage with 4-digit precision, thank you very much. And we do get, even though this is not the A model, we do get the 0.1 milliamps, at least the display digit is there anyway. So that is definitely 0.1 milliamps, whether or not, you know, it could be, as I said, just a software thing and it just counts up in tens and only has 1 milliamp resolution. I don't know. But anyway, it displays our power and our resistance as well. So let's put it in constant current mode. So ranges here, we've got 40 amps and 4 amps. So that doesn't give us, it doesn't change our display resolution at all anyway, so that's rather interesting. Our slew rate, our V on where it switches on at, our voltage limit 180 volts, it's 150 volt supply, so why it's 180 volts I don't know, and our constant current limit up to 70 amps. Once again, this is only a 40 amp supply. So what's going on there? And by the way, if I start using the knob, there is no velocity control. Oh, why? It's not hard to implement a proper velocity control for that. That's just ridiculous. So I can just type in 1 like that, and there you go. And I got to press like 1 amp. There it is. But like, nah, give me a velocity control. It doesn't work on any of the input parameters at all. So on constant voltage range, we have our selectable 15 volts or 150 volt range. That's all right, no worries. And our voltage, once again, the knob is almost useless. It's only for fine control. Frustrating. Anyway, we can set our voltage limit and our current limit once again. And our constant resistance range, there you go, anywhere from, anywhere down to 2 ohms on the 15k ohm range, but it also has a 15 ohm range as well. 15 ohm range as well, and our resistance can go down to 80 milliohms there. Neat. And our constant power mode, we don't have any ranges on that, it's just fixed at the watt level. So let's actually enter 200 watts because that's our limit. Can we go above that? No, of course we can't. Boom. Boop. Nope. Setting has exceeded the power upper limit. Thank you. Then we've got our other function modes here. Let's continuous config guide. I like this, how it's all just coming up like that. That is very comprehensive. And pulse config guide, once again, look at all the parameters you can set. Very nice. Read, apply. How do you... Oh, okay. We'll have to set those somewhere else, presumably. Toggle config guide, and then you've got the list mode as well. Automatically goes into the graph here. Shows you all your relevant parameters in a quite decent font there. And I'm liking this. I really am. It's quite neat. Anyway, the list thing is like a step-based sequence type mode you can go to, useful for systemized power supply testing, things like that. Now, what I'm really interested in is the battery mode, and let's have a look. Once again, voltage and current displayed, milliamp hours, watt hours, which is what, the true capacity of a battery, our timer there, but unfortunately, we can set the current, we can set our range from 4 amps or 40 amps, we can set our stop voltage, we can set our current stop as well, and or a timer-based stop, but we can't set a stop value on our watt hours. Why not? It's just a software thing. It can only do milliamp hours. You can't stop on watt hours. And that's where it'll switch on with the on voltage. Just give me watt hours. Anyway, let's click the Illuminati button and see what that does. Oh, that's our graph. That's our graph. You can see it starting to accumulate there. So the unlabeled Illuminati button. Some people say, I put this on Twitter and they said, oh, it's the CBS logo. Like, I have no idea about CBS. So, yeah, whatever. It's the Illuminati button. And, yeah, we've got our graph mode. So that means that when you're in, say, constant current mode, you can do the graph. So it's totally dependent upon constant power, depending on which mode you're in. I don't mind that. They could have bloody labelled it, though. And then the over modes is our overcurrent protection mode. You can just sequence, like do a step sequence mode for testing your supplies for power and current. So that's not bad at all. I like those 3 apps built in. And it looks like our on-off button, there it is. Load just comes up. Presumably, transient. And what does short do? Does it short out the terminals? I don't know what short does. RTFM. The most annoying part about this, though, is that I cannot select anything but constant current discharge. I mean, what if I want to test constant resistance mode, which is in the data sheets for, toy testing and things like that? I can't do it. I got constant current only. It's ridiculous. This is like just a software limitation. Why have a complete battery mode like this if that's all you're going to be able to do? It's ridiculous. Now for the finger test on these heat sinks down in here, of course this one's where we're not dumping any load into this at all. So of course that's completely cold. These linear regs down here, back of the finger, hang on, it is Rigol, so yay! Bloody hell, that's too hot to touch. Unbelievable. Have they done it again? Okay, so that one there is 80 degrees. Come on. This is not a rocket science, Rigol. That is too hot for a simple linear supply. I mean, like the junction temperature is well above that. That's just that, granted, okay, we don't have the top in the case, so I can sort of put the case back. I can put something on the top, and that's going to simulate the airflow. Let me do that, but that's just wrong. I'm afraid that the one next to it there is even worse. This one's up to 88. Oh, unbelievable. Okay, I've put the lid on the top, and you can see it going down. It's dropping. I've got just boxes on the top like that just to simulate, because the air in the side, the intake's going to be the same. Okay, it's getting down towards 75 degrees. So yeah, that's knocking 13 degrees off, but that is still just no excuse for being that high for a basic linear regulator when you have all that space inside. It's just insane. Now, that's not to say that it's, going to fail or anything like that. There's still margin inside, the die temperature of a 7805 or whatever can go up to, 120 degrees Celsius or something. But so it's not going to fail. I don't recall that being nearly as bad as I think it was over 100 degrees for the DP832 power supply, which they had to fix. But come on. No. Now, curiously, the Rigol DP832 powers up much, much quicker than the electronic load. Why? I can't remember the teardown, but they've changed processors or whatnot, and maybe changed OS. I don't know what's going on. But there's a huge difference. I mean, that's fine. This one takes forever, but whatever. Now, I've got it hooked up to the 832. I've got simple constant current load of 1 amp. We're getting 1.004 over here, and we're getting 0.9978. That's like a discrepancy of 0.6% between them. What the? That's way out of spec. Oh, I'm on the 40 amp range. Let's go. Oh, what? Turn off the load. You can't change ranges unless you have the load turned off. There we go. 4 amp range. No. It's exactly the same. Assuming that, let's just assume that it's 1 amp. That's 0.3% out, 0.2% out. It's supposed to be 0.05% plus 0.05% full scale. Seems out of spec. And let's just check the voltage, 29.977. And right on the terminals, where it should be measuring it, 29.981. It's not too far off, but technically that might be close to or out of spec as well. Okay, people wanted to know the current. Well, it looks like the DP832 is bang on, 1.005. I'm not going to quibble one least significant digit compared to the 7.5 digit key side here. So we're going to take that as absolute because, yeah, its accuracy is like order of magnitude better or something than what we've got here. And we're getting 0.9981. That's out of spec. Rigol, please explain. Okay, let's do our dreaded constant resistance mode. We've got it set to 10 ohms. Let's switch on our supply here, and absolutely nothing. I switched it down to 2 ohms. We're getting no hiccup in at all, even though you can see that the 3 amp current limit is enabled on the DP832. Nothing's hiccuping. Nope. Stable as. And the short button does exactly what you expect. It shorts it out, 0.01 ohms. So it doesn't do that with a relay. It does that using the MOSFET load to actually do that. Now, as for the graph functionality on this thing, the Illuminati mode, there's no way, like you can't, like there's no auto scale button or anything like that to just like auto scale that in. That would have been really nice. Please implement something like that, just so that you can see the fine detail in there. And we can choose our data. Current, U, is voltage, R is resistance, P is power. Why can't we do the voltage and current on the same graph? Why can't we have another y-axis over here and do them in different colors? Yeah, please, that'd be nice. And I've plugged in my USB stick here. It says it was detected, and I'm going to print, save in image. Great, I love that feature. Presumably, hopefully, but wah, failed. Why? Okay. Let's try another USB stick. Maybe it wasn't the right format or capacity or whatnot. Save in image. Come on. Unbelievable. Hey, check this out. I was just logging here. I press the utility button. It switches off the bloody output. Look. Why? That's ridiculous. Look at this. It does the same thing. It doesn't do it for option, but it does it for store. You push the bloody store button and it's there. Anyway, look, it looks like there's a D drive there. I presume that cow data, is that the C is probably internal. How do we get to D? Like that. There's a D drive there. Save. I don't know. Okay, whatever. What? What? Okay. I don't know. Do we have to do D? Do we have to select D before we did the bloody print thing? Is that what's going on here? How do you get rid of that? Oh, look at... Wow. It just... On. Okay. Print. Save in image. Is it going to work this time? Failed. Yay! I think I finally found a USB stick that actually worked. It just says save in image and saving. Oh, thank goodness. And it saves it in bitmap format. How quaint. Okay, let's go into the utility here. Have a look at all the interface stuff. GPIB, nice. USB, RS-232, nice, all the requisite stuff, and LXI LAN as well. I'm sure that'll work a treat. And there's the firmware versions and stuff for those playing along at home. System boot times, been booted 34 times, FPGA version, all the requisite stuff. Last calibrated 1st to the 9th. And yep, you betcha, we've got software options, LAN, official digital I/O, high resolution official. Is that the A version? Have I been upgraded? I don't know. Slew rate and frequency, because those three things, the high resolution, slew rate and frequency, seem to have been the major differentiators with the A version. So I don't know. Have I been given the A version and no sticker on it install. So maybe I have. Now, I don't mind the list mode here. It actually works quite good. Basically, you set the number of steps that you want as 6 maximum. I'm not sure. Anyway, what can we go up to? No? Heaps. So anyway, we can set it back to 2. So we'll go 2 steps, and then I've set... you just use cursor keys over here just to set, okay, we want 1 amp. We're in constant current mode. We can change our range. So we want 1 amp for a duration of 1 second. And then we want 2 amps for a duration of 1 second. And circles, loop, how many times you want to loop through. So we can now run that. And it should, hopefully, no? What's it doing? Oh, well, why isn't it going on to the next step? Hello, McFly. One other thing I noticed, if you've actually got this on and you go to something else, it'll go to that mode and switch it off. You shouldn't be able to do that. That's just wrong. You should, it should tell you, sorry, you've got to switch it off. Because usually when you switch it on, you're doing something. You don't want to accidentally hit buttons and cause it to goof up. Now, it looks like, why this isn't working, it needs to trigger to go to each state. It doesn't automatically do it based on the duration. You can do transient. I'm not sure what's going on there. Bus triggering. Is that like your interfaces, your RS-232s and LAN and whatnot, or your digital I/O interface where you can feed in an external signal and cause it to step through, but there's no like time-based mode or automatic or anything like that, so that when we start this, it just stays in the same duration there, and it's 1 second. It doesn't automatically go to the next. So, not sure what's going on there. RTFM maybe? Aha! Tran button. Let's go. There we go. Let's press it. Yes, there we go. It's sequencing through. There you go. You can see it's sequencing through. Green on each. Oh, no, sorry, because it only cycled through, twice. We only had 2 circles, but there you go. You saw it. You can sequence through. Nice. And you can apparently record that to USB as well. So if I go back, well, no, I just pressed on, and then trans, and boom, boom, boom. Boom, 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 and it should end, and it ended the recording, did it? Let's see what we got. Well, that's lame. All it did was record the voltage. Why can't it record all the parameters here for each step? It's just dumb. Okay, I'm going to do a battery discharge test. I've got a Duracell Ultra in there, fresh out of the pack. You can see I'm using the external sense lines here. I've just got it hacked in there a bit. How you doing? And I'm going to do a very brutal 1 amp constant current discharge, because you can't do anything else. You can't do constant resistance or anything. Bloody ridiculous. Anyway, I've got the stop voltage set to 0.8 volts. I don't care about the timeout. I don't care the current timeout. I don't care about stopping. 0.5 volts turn on. Everything's hunky-dory. It doesn't matter whether I go out of battery mode. It shows, I was mucking around just with one before, just to make sure the setup works, and it shows the previous info there. It doesn't clear it. Even if I go in there and, change the app or whatever. Look, anyway, let's do it. Let's start it, shall we? So here we go. Constant current discharge. 1 amp, and we should, presumably these will clear, the time will reset, and we'll start again. Let's give it a whirl. There we go. Alright, it's dropping. It's dropping fairly drastically already, as you'd expect, because it's pretty brutal, 1 amp on a poor, innocent AAA cell, but anyway, we'll eventually get a figure here. Now, we can actually call up the graph, okay? Look, there it is, right? It'll start, but we can't choose both. Like, we can't get the figure. Like, it's just like, why can't I have all the information on here and it resets the graph? What the hell is going on here? Like, I can't do both. That is just ridiculous. And we're done. That didn't take long at all. Battery test completed. I assume I press OK to get rid of that, and there it is. Of course, the load is disconnected, and so the voltage is actually recovering. It would have gone down to 0.8 volts on the terminals of the battery because we are doing the voltage sense down here. And there you go, for the record, 263 milliamp hours or 0.268 watt hours for a 1 amp discharge on a basically one of the best AA's you can get, the Duracell Ultra. So yeah, it's not great because AAA's aren't designed to handle 1 amp constant current loads. That's just crazy. You know, you'd use a AAA or higher for something like that. But there you go, it works. But yeah, it's crude. And look, if we go into our graph, where's our graph? Where's our data? Like, it's just ridiculous. Can we play back? Can we play back? Oh, maybe we should have pressed record and it would have dumped it to the USB stick. Damn it. USB was not detected. We've got to press record. Okay. Oh. But to record like this, I've got to be in the Illuminati mode, right? So I got, like, I don't know, back? Can I, like, go, if I go out of there, is it... Oh no, it's still in record, so maybe that actually works. Maybe that is going to work. Here we go, I'll start it again. Bingo. There's a bit more capacity left in that battery, of course, due to the electrochemistry recovery in there, due to the very steep discharge. But hopefully we're actually dumping that to the USB stick. So that'll be done in short order. We'll only get another few tens of milliamp hours out of that puppy, surely. Okay, we're done. Didn't take long at all. We got an extra 23 milliamp hours out of that. There you go. And once again, it's recovering. And presumably, if we go back to the... it's record in, like, I don't know. Do I just take the USB stick out? Like, do I press unrecord? What do I do? Like, I think it's only going to record. I'd be very surprised if it actually recorded this data. Well, I think I'm going to call it quits on having to play around with this thing for now. This was not designed to be a full review. It was just a tear down and an initial play around. And the kind of initial verdict is like, I don't mind the design and build of it, apart from that ridiculously hot, well, not as ridiculously hot as the DP832, that heatsink inside there. Anyway, the design of the front panel isn't the best. Those fonts are ridiculous, but at the end of the day, that doesn't really matter. It's about the functionality of it. I was disappointed by the battery mode. Some of the other modes are, you know, like it has all your basic load functionality. It'd take, by the way, a lot of work to extensively test all the different modes of a advanced electronic load like this one. So yeah, that would like be a 40-minute video in its own right, I think, if I did that. But there's like just basic things missing from the battery test, the display mode and stuff. The USB was, it has to be a certain format, and it didn't even tell me that it was wrong. And it's just, there appears to be accuracy issues with this thing, maybe more extensive requirements on that. You know, like it's only an amp, it's not like 40 amps or whatever. It was like, it should have been better than that. So I don't know what's going on there. Rigol need to look at that. And I don't know, there's just not a huge amount of spit and polish on this thing. It's like, yeah, okay, it's a load, it'll do the basic job, but there seems to be, you know, quite a few issues with it, which they can fix in firmware updates and stuff like that. But initial impressions are that it's just a run-of-the-mill electronic load, really. You know, bang per buck, there are better ones. You know, if you just want a basic electronic load, you can get one for $200-300 on eBay, one of those rip-off brands, and they do more than an adequate job just for a basic electronic load for testing power supplies or something like that. So at the end of the day, it's like nothing hugely to recommend this thing yet. You know, if they improve the functionality and solve the whatever accuracy issues it might have, and if they gave you the A model, all of it, like I presume that mine has the extra A functionality, but it doesn't have the label on there, but those options are a ridiculous price. Like, what was it, $400, or was it double or something just to get the A model? It's crazy. Just have one freaking model, maybe two if you want the difference between the 300 watt and the 200 watt model, fine, but Like, it doesn't justify the price difference. So, no, they haven't got themselves a killer electronic load here, I'm afraid. It's just, meh, another electronic load on the market. They've all got their own little quirks and issues and whatnot, and this one is no exception. So there you go. If you like this look at the Rigol DL3021, please give it a big thumbs up. Full of frame, thumbs up. And if you want to discuss it, down below. Catch you next time.